Hello everyone, welcome to the Skill Talk. So we will be continuing our thermography series, and I hope that you have go through the all 4 videos that we have made especially for thermography. Okay, so today we are going to discuss the important thing that, let's say that if you are capturing a thermal image from your camera, so it's mostly influenced by the 3 factors. Okay, so one will be the emitted energy, and the second is the reflected energy, and the third is the transmitted energy. So normally whenever any light falls on any of the objects, so normally these three phenomena happens there on that body. One is the emitted energy, second is the reflected energy, and the third is the transmitted energy. So if we understand these things correctly, then definitely you know that the measurements that we are taking through the cameras, that will be accurate, and we will not, we can avoid the misdiagnosis of the fault. Okay, so let's start one by one. So first we will discuss about the incident energy. Okay, so what is this incident energy? Whenever the infrared radiation reaches a surface, okay, so we call it, you can say, the incoming energy, or it's also known as the incident energy. Overall, in the general term, you can say that whatever the light is falling on the object is known as the incident light, or you can say the incident energy. So that incident energy does not vanish, because it splits in normally into the 3 parts, or you can say the 3 factors that we have just discussed before. So what happened that, let's say one light is falling on one of the object, so some of the light will, or you can say that some of the energy will be emitted by the object itself. Okay, it will be absorbed by the object, or some it will be reflected back like like a mirror, and some will be transmitted through the material. Let's say if the material allows to pass this infrared radiation, or you can say the IR waves, so some of the energy will transmitted through the material. So we will be discussing now these 3 factors one by one. So let's start with emitted energy. So what is this emitted energy? Emitted energy is the important component in the thermography. Why? Because see, this is the IR energy that comes directly from the object due to its own temperature. Okay, so the hotter the object, then that means it emits more energy. But here is the important factor, that is that this emission is also depend on the emissivity of that particular material. Okay, so that means it's also depend on the property of a material that is known as the emissivity. So what is this emissivity? That we have already discussed in our last video, but normally it's like, describe that how efficiently a material can radiate heat compared to a perfect black body. And what is the black body? Black body is, you can say, that's the body which is emitting 100% of energy. Okay, so so let's say that you have put one black paint, or rubber or skin. All these they are all the high emissivity material, so their emissivity is it's very high, near to the 1, or you can say 0.95 or 0.96 like this. Okay, and if there will be any kind of a shiny material, let's say aluminium, stainless steel, so like such kind of material will be having the low emissivity. So what means the low emissivity? That means maybe somewhere 0.02 or 0.015 or less than that. Okay, so thermal camera always calculate the temperature mainly from the amount of heat or amount of energy emitted from the object. So that's why it's very important that we should set the emissivity correctly in our camera. Okay, so let's move to the next one, that is the reflected energy. As you know that the shiny or the smooth surfaces, they reflect a lot of energy, right? So that means that not all the objects absorb all the heat or all the energy that is coming from the environment. So some of them reflect it also. So what happened that such kind of objects may make you confused by creating a false hotspot on your images. So we will take one example here. Let's say that we have point our camera at a let's say stainless steel bus bar. Okay, and since we know that the stainless steel is having the low emissivity, that means it's having having the high reflectivity. Okay, so and once we did the camera towards that stainless steel bar, and we see a bright hot spot, but in reality it is just a reflection of your, maybe of your body, or maybe somewhere, you know, some other heating source nearby to that tank. Okay, so that's why it's very important that we should put always the reflected apparent temperature in our camera. So what is this reflected apparent temperature? It is the estimation of the heat reflected from that particular object. So how you can, you know, reduce this reflection errors? So there are few things that you can do in such cases, that you can use a tape, okay, or a dark paint dot that is having the high emissivity, or there is another way also that you can change the viewing angle. Let's say that you are standing straight ahead of that object, and your object, that your own body heat is reflected by that object. So you can give one angle to the camera so that it can be avoided. And the third one is that we can measure how much the reflected apparent temperature is there from that object by using a foil, and we can just feed it into our camera so that it can be avoided. Okay, so let's move to the next section now, that is the transmitted energy. So the third component is the transmitted energy. So some materials, what happen, that they let infrared energy pass through them. So it mainly depends on the wavelength. So let's take an example. Let's say there is a normal window glass is there. So since you know that it's a transparent, so visible light can be easily transferred through that. But if it's it is an opaque for IR waves. So now let's say that you want to take an IR image of a particular panel, and we know that IR image can't be can't pass through the normal, or you can say the standard window glass. So in such cases, what you can do, we will be using the special kind of glasses that makes from the material like germanium or the zinc selenide. Okay, so what happened, that these materials allow IR waves to pass through them. So this is why we cannot just scan through the normal glass with our camera, because it blocks the IR radiation. Now let's discuss the energy balance equation based on these three factors. So since we know that the emissivity plus reflectivity plus transmittivity, that is equals to the 1. Okay, and if let's say that the object is opaque, so is for such material the transmittivity factor is almost 0, or you can say 0, right? So in that case, this equation will change. What happened, that the transmittivity we will be putting 0, so emissivity plus reflectivity, that will be equals to 1. So this equation you see that, okay, emissivity that will be equals to the minus of the reflectivity. So what that mean, that if the surface is having the low emissivity, that means it must have the high reflectivity, or you can say opposite, that if the surface is having low reflectivity, then it should have the high emissivity. Okay, so let's take a practical example here. Let's say a thermographer, or let's say you are scanning a polished steel tank and you see a bright area, and we are assuming that it's overheating. Okay, so but after let's say after placing a black electrical tape, which is that the black electrical tape is having the high emissivity factor, so it definitely the emissivity will be more than 0.95 on the surface. So the measured temperature drops significantly when you do this. So the brighter spot, what that mean, that the brighter spot that we are seeing earlier, it wasn't the heat, it was just a reflection. So this is the example that why we must always separate the emitted energy from the reflected and transmitted energy. Okay, so I believe we have covered this topic, so let's summarize it. So what we have important thing that we have learned here is that the incident infrared energy always split into 3 important factors. One is the emission, one is the reflection, and another one is the transmission. Okay, also we learned that thermography mainly relies on the emitted energy, but reflected and the transmitted energy can mislead us. And also we have discussed how to avoid this reflection and the transmission. And last is that since we know that the emissivity and the reflected temperature are very important to know for any of the material, so before doing the thermography, so it's always important to know the material properties, okay, before initiating the thermography process. So thank you guys for being with us. So now we are ending this video, and we believe that our thermography series is helping you guys. Okay, so thank you for watching Skill Talk, turning skills into power.